Well, we're back here with part 2 of day 12 notes. Next thing I'm going to talk about here is voltage. Voltage is the force or the pressure. I like the word. Um, it's voltage is the pressure that causes current to flow. It's measured when we talk about electricity. That pressure is measured in volts. Um, so if you ever want to compare it to something, think of it as like pressure. How much pressure is there behind the water? Do we have a little bit of pressure, or do we have a whole lot of pressure? When the faucet is switched off, is there any pressure? Well, yes, the pressure is pushing against the pipe tank in the faucet. There isn't any current, but yes, there is pressure. When the faucet is switched on, is there any pressure? Yes, the voltage pushes flow or current through the system. So, yes, as long as we have a battery hooked up, we're going to still have that pressure. Battery provides a voltage that will push current through the bulb when the switch is on. All right, so the battery is what supplies that voltage. The battery is what supplies the pressure. Resistance. What happens to the flow current if a rock gets lodged in the pipe? Well, if we were to bring in here and bring a rock or put a sock or something in the pipe, what would happen? Well, that would be a huge amount of resistance. If you get enough resistance, what happens then is the water stops flowing. Well, if we put a big enough resistor, a really, really large resistor, we can virtually stop the flow of electricity as well. If we were to come through here and let's say maybe just one napkin gets put into the pipe, well, it's going to provide a little resistance. You're going to have a little bit less water, but you're still going to have a flow, a current. It's the same way with electricity. We could use a little resistor and we would still have most of our electricity, most of our current. What you're going to find out is like it says up here, it's the opposition. Resistance, resistance and current are inverses of each other. And what that means is if we have a lot of current, it means we have little resistance. If we have a lot of resistance, we have very little current. So that's the relationship that exists between those two and will always exist. All right, on here, measuring voltage. And again, those of you who had ICP or physics can have a little bit of an advantage here, but measuring voltage is always measured in parallel. And what that means is we're always parallel means we're going to give the electricity two choices. So for example, on this resistor here, if we wanted to measure the voltage across this, what we would do is measure both sides. And now the electricity has two choices. It can go through the resistor or it can go through the multimeter. So we've hooked to measure the voltage. We're hooking it up in parallel, and it's going to allow us to get a measurement up here of some certain amount of volts. Likewise, we do the same thing with the light. It'll go through the resistor, or it can go through and into the multimeter. So whenever we want to hook or check the resist or the voltage on an object, we always want to check it in parallel. Multimeter meaning we can measure probably voltage, current, resistance. You can't always measure all three, but typically a multimeter is going to allow you to measure all three of them. Ours look a lot like the one over here on the right, but as you can see, all four of these are basically multimeters. Measuring current. Now, if you want to measure current, meaning you want to know how many electrons, how much charge is going through here, we're going to measure that in series. And typically, what they're doing by connecting it here, what you're going to do is you're disconnecting this wire. All right, you're making that wire no longer a choice. So your voltage, your current, your electrons go through here, through the switch, and because this wire is no longer here, the current then has to go into the multimeter, back through the other branch, and into the resistor. So now you hooked it up in series. You've given it no choice. Series means there's only one path. It doesn't have a choice. All right. You're going to go into the multimeter, back out through the resistor, and so forth. The same thing over here with the light. If we're going to hook up the light, we would have to disconnect. We'd have to disconnect this wire. All right, and we'd have a prong. Probably hook this prong right here after the resistor, and then take this wire and bring it over here, and that will be in series because it would go into the multimeter, back out of the multimeter, and then through the light. That's the only way you can measure current then. You have to hook it up in series. Well, let's talk a little bit about Ohm's law. Ohm's law is V equals I times R, where voltage is equal to the current times the resistance. Sometimes we use this little chart up here. I'll put a V up here. And if you ever want to solve for a variable, you just cover up the letter you want to find. So if I wanted to find voltage, all right, cover it up. How would you find voltage? You take I times R. But let's say I wanted to find resistance. If I wanted to find resistance, you cover it up. And then that tells us to take the voltage and divide by the current, if that makes sense to you. We can talk more about that if you guys ask, but most of you guys have had physics, and this is going to be a review. For a couple of you, because you're such strong math students, I don't think it's going to be very difficult. Once again, we're talking about the abbreviations. Down here at the bottom, I wanted to show you these are all three equations. It's the same equation, except it's just been solved. We take this right here, and in the first case, they solved it for V. If you cover up the V, V equals I times R. And that's our first one. If you want to solve it for I, cover up the I. What do you get? You get V over R. And in the last case, if you cover up the R, you get V over I. So it's all three equations, but all three are the same. Flashlight shown uses a 6-volt battery and has a bulb with a resistance of 150 ohms. When the flashlight is on, how much current will be drawn through the battery? Well, you can use the chart like they do, which they're suggesting, but I think that's going to be a little bit more cumbersome for you guys. Most of you guys are simply going to go V equals I times R. All right, they tell us the voltage is 6 volts, so I'm going to plug this 6 volts over here for voltage. The current, all right, they say how much current will be drawn. Well, I'm going to put I because I don't know that. And they tell me the resistance is 150 ohms. Solve for I. If I just simply take 6 divided by 150, I get 0.04 amps. But a lot of times we won't refer to that as 0.04 amps. They'll simply call that 40 milliamps. And that's just using the metric system. The amps would be like grams, liters, meters, whatever. And they're taking it and they're saying, if we move the decimal 3 spots to the right, we have grams, or in this case we'd have amps, we have deciamps, centiamps, milliamps, those should all be capital A's. Well, that's 1, 2, 3 spots to the right, so we moved it over 1, 2, 3 spots, and that gave them 40 milliamps. Well, hey, that's our second bit of notes. I tried to get through it as quickly as I could because I know you guys had a lot of notes to take tonight. Hope you appreciate it, and